पर भी n big omega is basically least lower bound, so that means we have to figure out a function c of gn which is lower bounding this fn, मतलब इससे lower bound कर रहे हैं, ठीक है. So that is the lower bound. So fn big omega is represented like this, fn equal to, this is the omega symbol, this one, both equal to gn, and the same condition will apply, but the thing is that in case of big omega we have to find the lower bound. That means function should be greater than equal to c of gn. That means the function is having higher value after a certain input value n naught, and c is greater than 0, n naught is greater than equal to 1, so that there must be at least one input, and n should be greater than equal to n naught. After this particular value, the function fn is always higher than c multiplied by gn. So that means we have able to figure out c into gn. So that means it is giving us the lower bound. So this is another example. Here we are changing the order because suppose function is n square, so n square is always greater than equal to n. n square हमेशा greater than equal to n रहेगा. So that's why we have taken a simplest example. Order change कर दिया इधर, but the thing can be like this. So c is equal to 1 and n not equal to 2 for this particular value, or for all values of n greater than equal to 2, the condition will be true. Suppose if I put n equal to 2 here, it will be 4, and on other side it will be 1 multiplied by 2, that is 2. So 4 is always greater than and equal to 2. So that means in this case we are able to predict the value of n naught as 2. Suppose n naught हम 1 कर देते हैं, तब भी ये condition true रहेगी, because n square will give us 1 and on other side n will always give us 1. So that means both are also again equal. So in any value of n naught we can say that this condition is true. Even I can choose this one also. So after this one it will be always greater than or equal to this particular value. So this is how we can say this. Then we have big theta notation. Big theta giving us the average bound. So that means big omega is giving us the lower bound. That means it is talking about the best case running time of an algorithm. And big theta is average bound. So that means it is talking about the average case running time of an algorithm. It is represented by this theta symbol. It can be like this, or we can have some lines over here just like this. Both are same. So what is the meaning of this f of n is equal to big theta of gn? So it says that there exists some positive constant c1, c2 and n naught also. For all values of n naught, the condition of this should be true. Like we should able to find out a function which is less than equal to this fn, and it should be greater than equal to this fn for some constant c1 and c2. So that means what we are saying is if function fn is equal to big theta of some function of gn, so f of n is equal to big O of gn, and simultaneously f of n is equal to big omega of gn. So we have to find out some conditions. Based on this should be true. So we are taking this example, n equal to n big omega of n square. So in this case we can prove this thing. We must find out a value of c1 and c2. Based on this, n equal to big theta of n square is always true. So this is how it is visualized. This fn is bounding these two functions. This is higher bound and this is lower bound. That means this is moreover about big O, and this is about your big omega. So this is how the value of n naught can be there. Based on this, both the functions are always greater than this fn or less than equal to fn. Let us take one example. Suppose this is the running time of an algorithm based on the algorithm having some third order operations based on the value of n or inputs. So we are saying that this is bounded by this n cube, which is big theta of this n cube. So suppose c is equal to 21. Why we are taking 21? Because based on this n cube we have to associate some c. So suppose for c1 we have taken this as 21. So as 20 is there already, so we have taken a higher value than that, and n naught is equal to 10. That is also a random choice based on this coming out 1000, so we are taking that n naught should be 10. So based on this, suppose we are able to perform this operation, 21 n cube, that is this side, is greater than 21 n cube plus 7n plus 1000 for all values of n greater than 10. If we take 20 n cube on this side, so it will give us n cube, and other side will have 7n plus not 5, this should be 1000. So it should be 1000, so it will give us 7n plus 1000 as the value on the right hand side for all values of n greater than 10. So if I figured out this, suppose the value of 10 I put is n I put is greater than 10, so based on this it should be greater than this. So 10, if I multiply it with 10 even, so it will be 70 plus 1000, 1070, and this will be 1000 only, so it will be less than, but I am saying n greater than 10, so it will be 11 here, and 11 cube will be higher than this particular total sum. So this is true in this case. If I choose on the next side c as 20, so that means we are talking about a different value of c, that is c1, c2, and n not equal to 1. Based on this I am checking this, so we can say that for all values of n greater than equal to 1, this condition will be true. So if I put n here as 1, it will be 20 on this side, and it will be 20 plus 7 plus 1000. So it will be always less than this. So that means we are talking about the big O notation. So here we are talking about big O, and here we are talking about big omega. So in both the situation, the condition is true for some value of C1 and C2. So this can be your C2 and this can be your C1. Based on this, I am able to calculate a function which is both upper bounding and lower bounding this particular function based on some value of constant C1, C2 and some value of n naught or n. So this is moreover about our asymptotic notations, all three. Next is abstract data types. What is an abstract data type? It is basically the specification of the data type within some language. That means we are not concerned about the language, and independent of an implementation. That means there is no implementation. So we have heard about data types which are like primary, built-in or user-defined. So what is the meaning of this abstract data type now? Abstract data type is basically a collection of data and associated operations for manipulating that data. So it is almost looking similar to your data structures, but what is the difference? Difference is that it doesn't specify how the data type is implementing. So abstract data type doesn't specify how the data type is implemented. So in case of data structures, we are able to identify like stack, queue and linked list, how they are implemented. We know the process of implementing them, that completes the data structure. But in case of abstract data type, it is moreover about the interface for any data type with functions as well as data. In normal data type, we are only concerned with the data, not their implementation and associated operations. Like integer, character, float, we are not concerned about their representation or associated operations. We are moreover concerned about the data. But in case of abstract data type, it is data plus associated operations, but without implementation. So that is how it is different from the data structure. And if we talk about data structure provides the implementation for the abstract data type. Like for example, we can have stacks, we can have queues, we can have list. So all these can be the examples of data structures which are implementation for this ADT. So we can have stack, queue and list. When I am writing here. In case of object-oriented programming, what will be an abstract data type? An abstract data type and its implementation together will make up a class. In case of object-oriented languages, where object is the topmost level of hierarchy, so object is the thing on which every object-oriented programming language is based. So if we talk about that language, this ADT will be, or example of ADT and its implementation will be class, and it is almost similar to structures that we find in C programming language. Okay, but in case of class, we used to have data type as data members and functions which are associated with that particular type along with their implementation. So that means class is an example for ADT along with its implementation. If we take the generic structure of a class, it is moreover like an abstract data type in which implementation details are hidden from the user and protected from the outside access, which is referred as encapsulation in case of object-oriented languages like C++. C++, you will find out this encapsulation mechanism. An example of encapsulation will be your class, but once the class is implemented, we are able to implement the abstract data type. So this is moreover about the introduction between abstract data type, and there is a difference also between data structure and abstract data type. So that's all for today.